In this video, you will be introduced to the basics of correlation. Correlation is a statistical measurement of the relationship between two variables. The relationship between two variables is either linear, and a linear relationship is one which can be modeled by a straight line. So on a scatter plot, we use the x-axis to represent our independent variable and the y-axis to represent the dependent variable. So this particular point on the scatter plot says that when x is this much, y is that much. So each point corresponds to an x value and a y value. Each point can be described using an x value and a y value. If the relationship is not linear, then it is nonlinear. And a nonlinear relationship is one which is modeled by some other curve. Not a straight line, but some other curve. Like, for example, this one here. So we can draw this shape to model our data. Correlation specifically measures linear relationships. Specifically measures linear relationships. And so if two variables x and y, where x is the independent variable and y is the dependent variable, if these two variables are correlated, then there may be a linear relationship between x and y. In other words, when you plot the different values of these variables on a graph, then you can draw a straight line through the data. If two variables are not correlated, then that does not imply that the two variables are not related. It may be the case that they are related, but it's just that they're not linearly related. Their relationship, when you plot it on a graph, the different values, when you plotted them on a graph, you would not get a straight line. You may get some other curve. So it might be the case that the two variables are not correlated, but they are still related. Here, we see that there are three types of correlation: positive correlation, negative correlation, and no correlation. And a scatter plot, which is what we call these graphs, a scatter plot is useful in that it shows a plot of the data and a visualization of the type of correlation present. In this example, we see that in this graph, we see that as the independent variable increases, so does the dependent variable. And we draw a straight line through the data set. This straight line would have a positive gradient, or it would be an upward sloping line. And an upward sloping line is an indication of positive correlation. On the other hand, in graph 2, we see that as the x value increases, as the value of the independent variable increases, the value of the dependent variable decreases. When the independent variable is at this point, the dependent variable is that value there, which is this high. And as we increase the independent variable to this amount, the dependent variable actually falls to that amount. And so this data can be modeled using a, a straight line with a negative gradient, which we can call a downward sloping line. And a downward sloping line is an indication of negative correlation. In graph 3, we see that when the values are plotted, there seems to be no relationship, in that we can't really draw a straight line through this data, because the data does not appear to be either upward sloping or downward sloping. And as a result, there is no correlation between the variables x and y. In these scatter plots, we see that the variable can be positive, negative, or no, as indicated earlier, but they can be classified according to their strengths as well. The relationship is described as being perfectly positive if when the data points are plotted, they lie on a straight line, so that this straight line can pass through all of these values. There is high positive correlation if the values still follow an upward sloping line. However, the values are more scattered, so that not all of them would lie on this straight line. And the more scattered the values are, the weaker the relationship is. So in the perfect positive correlation, the data points lie exactly on this straight line. In high positive correlation, a straight line still exists, upward sloping line, but now the data points are a bit more scattered. And in low positive correlation, the data points are greatly scattered. For the no correlation case, again, we can't seem to draw a straight line through this data set here. And so there appears to be no correlation between the two variables. What was said about positive correlation can also be said about negative correlation. It's perfectly negative if we can draw a perfect downward sloping line through the data. If the data are more scattered, so that this line passes through not all of them, but a few of them, it's high negative correlation. And as the points get more scattered, the strength of the correlation decreases. Now, this is an exercise where you have to test your understanding, see how well you understand correlation. So for each of these scatter plots, you're going to either write in your book or post it in the Facebook group, the Integrated Mathematics group, the type of relationship seen in each one of these plots.